before we can do any proofs, we have to build up some tools of logic. So one of those is a conditional statement. All right, it is conditional because it's going to have a condition that must be true in order for the other part to happen. So there are two parts in this, okay? So there is the hypothesis, which is usually associated with the word if, in an if-then statement. And there is also the conclusion, which is usually associated with the word then. So we could write this as a mathematical statement with the arrow as a symbol that says P implies Q. Okay, as a sentence, you could say if P, then Q. For example, in our first sentence here, if it is raining, so the word if tells me that it's the hypothesis. If it is raining, then there are clouds in the sky. So now that is my conclusion because it says then. In the next sentence, if two angles are a linear pair, then they are supplementary. Looking at my first two examples here, we're going to identify the hypothesis and the conclusion for each of these statements. Statement A, if you study for the test, then you will pass. In example B, if B is between A and C, then AB plus BC equals AC. Next, we're going to practice rewriting some conditional statements so that they are in if-then form. So we're going to start out with if, okay? So the statement starts as, all sophomores take geometry. So that would be, if you are a sophomore, okay, so that would be the hypothesis, okay? And the next part would be, then you are taking geometry. Okay. This may or may not be a true statement when we write it. We're going to get to the truth value in just a second. Our next example says two angles are supplementary if they form a linear pair. So here the word if does appear, but the word then doesn't. So I just have to rewrite it. If two angles form a linear pair, then they are supplementary. Okay. In our next example, we have that A minus B is less than A only if B is a positive number. We're going to come back to that word only in a little bit. So for now, if B is a positive number, then A minus B is less than A. In geometry, statements can either be true or false. There's no maybe, okay? So it's either always true if every time the hypothesis P is true, then the conclusion Q is also true. But if there is any counterexample in which the hypothesis P is true and the conclusion Q is false, then the conditional statement overall is false. So this is similar to what we saw in 2.1 with proving our conjectures false, and if not, we had to come back and look at it. So in order to verify a conditional statement, okay, if it's true, then we're going to have to show that every time the hypothesis is true, the conclusion is also true. All right, to find a conditional statement to be false, then all we need is a single counterexample, in which case the hypothesis is true, but the conclusion is false. Okay, so we're going to make the hypothesis true and then look to see if that conclusion always follows or only sometimes. So let's look at our examples. We're going to determine whether each conditional statement is true or false. Okay? If it's false, it's going to be because we provide a counterexample. In our first example, the hypothesis is if a number is odd, and the conclusion is then it is divisible by 3. Well, let's just start by listing some odd numbers. So we have 1, 3, 5, 7. So 3 is divisible by 3, but 1 is not, 5 is not, 7 is not. You could pick any odd number that is not divisible by 3, so we are going to say false. And our counterexample is, let's say, 5. In our next statement, if an angle measures 92 degrees, then it is an obtuse angle. Well, in this case, there's only one instance in which an angle measures 92 degrees, and that's when it does. And by definition, an obtuse angle is greater than 90 degrees. Since 92 degrees is greater than 90 degrees, this statement is true. For C, our hypothesis is if x squared equals 16, and our conclusion is then x equals 4, we might be inclined to say that this is true because the square root of 16 equals 4. But what about if x equals negative 4? Then what is x squared? Well, negative 4 times negative 4 equals positive 16. So this statement, I have a counterexample, so this statement must be false, and our counterexample is when x equals negative 4. So if we have a statement, we can negate that statement and write the negation by writing the negative, okay, or the opposite of the original statement. So it will have the opposite meaning as well as the opposite truth value. Okay, so it means you would write not P, and the symbol is the squiggle in front of it. Okay, so let's look at writing each of these statements, all right, but now negating them. So if P starts out as it is raining, then the opposite of that is it is not raining. In B, all right, our original statement is that the measure of angle A equals 30 degrees. So you could write a sentence that says the measure of angle A is not 30. It's not 30 degrees. Or you could write a mathematical statement. All right. So you could say the measure of angle A does not equal 30 degrees. In either case, this works. Again, in part C, we have a mathematical statement for P, and that is that x is less than 2.3. So the opposite of being less than is to be greater than. So you would say x is greater than 2.3. But in this case, we're not quite done because this isn't the exact opposite meaning, because this hasn't ruled out one particular value, 2.3 itself. So in the original statement, x was less than, so when I negate this statement, it must be the exact opposite meaning, so it has to be greater than or equal to. In example D, the statement is that angle DBA is not an acute angle. And while you could say that, to negate this, that angle DBA is not an acute angle, your English teachers would probably be pretty unhappy with you, and it could get pretty confusing. So, in this case, we're just going to take the word not out of the sentence and say that angle DBA is an acute angle. For any given conditional statement, so P implies Q, there are related conditionals, and there are 3 of them, and those are the converse, inverse, and contrapositive statements. The converse of a conditional statement, P implies Q, is going to be the statement that is formed by switching the hypothesis and the conclusion of the conditional. So if I start out with if P then Q, the converse is if Q then P, and now we write it with the symbol Q implies P. So in our example, our original conditional statement is if it is raining, then it is cloudy. So we now switch our 2 parts of that statement. So now we say if it is cloudy, then it is raining. So let's look at some examples of writing the converse based on the conditional statements. Okay? Then we'll determine the truth value of the conditional statement and its converse. So, in the original one, if the measure of angle A equals 30, then angle A is acute angle. So, when I switch those, okay, if angle A is an acute angle, then the measure of angle A equals 30 degrees. So, our original statement, the conditional, okay, if the measure of angle A equals 30 degrees, then angle A is an acute angle. That is true because that is part of the definition of an acute angle. But the converse, if angle A is an acute angle, then the measure of angle A equals 30 degrees. Well, that's not necessarily true because I can think of, what about if it equals 45 degrees or 62 degrees? Those are both less than 90, and so the converse is not true. All right, let's look at the next one. If 2 segments have the same length, then they are congruent. Okay, so when I rewrite this by switching those 2 parts of the statement, if 2 segments, because we're still talking about those, so that the noun is going to stay there, if 2 segments are congruent, okay, then they have the same length. Now in this case, the conditional statement and the converse statement are both true, okay, because these are basically the definition of congruent, okay, when applied to segments. Okay, next one, if you are in geometry, then you are a sophomore, okay? So we're going to say, when we write this, if you are a sophomore, then you are in geometry. Okay? So, the conditional statement, all right, if you are in geometry, then you are a sophomore. Well, we can provide a counter example of a freshman being in geometry, so that is false. And the converse, if you are a sophomore, then you are in geometry. Well, there could be a sophomore in algebra 2, so that one is also false. All right, one more. All rectangles are squares. Well, here the hypothesis is it a rectangle? And the conclusion is that it is a square. So let's rewrite this. So a square is a rectangle. Okay? Now in this case, the conditional statement, the original one, is actually false because not all rectangles are squares. Okay? So I could have a 2 by 3 rectangle, and that's not a square, but all squares are rectangles. So the converse is true. The next type of related statement to an original conditional statement is the inverse. So if our original statement is if P, then Q, then the inverse is made by negating both the hypothesis and the conclusion of the original statement. Okay? So if it started out as if P, then Q, the inverse is if not P, then not Q. Okay? And so our symbols, all right, so not P, then not Q. All right? So if our conditional statement was if it is raining, then it is cloudy, I negate both portions of that to get if it is not raining, then it is not cloudy. The third type of related conditional is a contrapositive. Okay, so in this case, we're going to take what we did for the converse and what we did for the inverse and do both things. Okay, so you're going to both negate and switch the hypothesis and the conclusion of the original conditional if P, then Q. So the contrapositive becomes if not Q, then P. And so our symbols would be not Q implies not P. So going back to that same conditional statement, if it is raining, then it is cloudy. The contrapositive switches the order. So if it is not cloudy, the negation, then it is not raining. So in summary, a conditional is any statement that's written in the form if, then. Okay? We're going to go if P, then Q to talk about the rest of them. The converse exchanges the hypothesis and conclusion. So it switches the order. Okay? You haven't changed any of the statements, you just converted the order. The inverse is formed by negating the hypothesis and the conclusion. So the inverse, you can kind of think of it as an opposite. Okay? And so I'm taking the opposite of each part. The contrapositive, okay, is the combination of those two. So I both exchange the hypothesis and the conclusion, and I negate both of them. So let's practice that. All right, let's start out by identifying the hypothesis and the conclusion of this conditional statement. So if you live in Houston, that's if, so that's hypothesis. Then you live in Texas, and that's the conclusion. So in this case, all right, we're going to go through, we're going to write the other three, and we're going to tell whether each statement is true or false. So let's start with the conditional. If you live in Houston, then you live in Texas. That is true. Okay, so now we're going to look at the converse. Okay, so converse, brand of sneakers, you could switch feet, might not be comfortable, but you can switch them. So converse is switching your hypothesis and conclusion. So if you live in Texas, then you live in Houston. That one is false. Maybe you live in Austin. Okay, now the inverse, I leave the order the same, but I make them the opposite. So if you do not live in Houston, then you do not live in Texas. Well, this one is also false. Because, again, if you lived in Austin, you don't live in Houston, but you do still live in Texas. All right. Lastly, we have the contrapositive. So now I'm going to switch the order and negate them. So if you do not live in Texas, then you do not live in Houston. And that one is true. Because if you're not living in Texas, there's no way you're living in Houston. Okay, now for one that's a little bit more mathy. So our conditional statement, if two angles are vertical angles, then they are congruent. In this case, that is a true statement. And then now we have to look at the converse. So I exchange the order. If two angles are congruent, then they are vertical angles. Well, I could have angles that are congruent, but not opposite each other when two lines intersect. So in this case, the converse is false. The inverse, all right, is when I negate both parts of the statement. So if two angles are not vertical angles, then they are not congruent. So again, I could have congruent angles that aren't vertical angles. So this one is false. And finally, our contrapositive. Okay, so I exchange the order and negate both parts. If two angles are not congruent, then they are not vertical angles. In this case, that has to be true, because if they're not congruent, then they don't match the definition, or part of the definition, of vertical angles. So this one is true. As you may have noticed in those last two examples, the conditional statement and the contrapositive have the same truth value in both cases. So those are equivalent statements. So they are both always true or always false. Another set of equivalent statements are the converse and the inverse statement. Those are also equivalent statements to each other. So we're going to write the converse, inverse, and contrapositive of the following conditional statement. And again, we're going to tell whether each statement is true or false. So the conditional is, if it is raining, then we will not practice outside. This is a true statement. So we're going to look next, actually, let's go to the contrapositive first, because we don't have to do these in the same order. So the contrapositive is my equivalent statement. So it's going to be if, all right, the opposite of we will not practice outside is we are practicing outside if we do practice outside. Okay, and then the original hypothesis was if it is raining, so negating that is then it is not raining. Okay, so again, because these are equivalent statements, they are going to both be true or both false. the conditional is true, so the contrapositive is true. Okay? So now we're going to look at the converse of the original statement. So now we just exchange the order. So if we do not practice outside, then it is raining. Okay? And the inverse is when I negate both parts. So if it is not raining, then we practice outside. So if we assume that it's a school day, then these are both going to be true statements. If it's not a school day, then they would both be false statements. Again, they will always have the same truth value. A biconditional statement is a single true statement, all right, that combines a true conditional statement and its true converse, okay? So this is going to be a statement that says if and only if, okay? So if P, then Q, and if Q, then P. And those will all be true things, okay? So now the symbol is a double-ended arrow, okay? So a biconditional statement is true only when both the conditional statement and the converse statement are true, okay? So we're going to rewrite this first one as a conditional statement, okay? And then its converse. So an angle is a right angle if and only if it has a measure of 90 degrees, okay? So the two parts of that are an angle is a right angle and it has a measure of 90 degrees. So the conditional statement, if an angle is a right angle, then its measure is 90 degrees. The converse is I switch that order. If an angle has a measure of 90 degrees, then it is a right angle. In our next example, we're going to determine if this biconditional statement is true or false. So the two parts are if x equals 3 and if x squared equals 9. So let's start out with writing the original conditional. So if x equals 3, then x squared equals 9. In this case, the conditional is true. Now we have to look at the converse. If x squared equals 9, then x equals 3. Uh-oh, that one's false. Because what if x equals -3? So in this case, I have not met the requirements for my biconditional statement to be true. So because one of these is false, the whole thing is false. Okay, now we have a true conditional statement. If a number ends in 0, then the number is divisible by 5. We're going to write the converse and then determine if the converse is true. So the converse, I exchange the order. So we're going to write the converse. If a number is divisible by 5, then it ends in 0. Okay, and to determine its truth value, well, I can think of a pretty easy counterexample, making it false. And that counterexample is when that number is 5. It's divisible by 5, but it does not end in 0. You may notice that there will be a lot of definitions that are biconditional statements, so you can read them forward or backward. So you can give the term first and then the definition, or vice versa, okay? But not all postulates can be written this way, although some of them can. So we're going to write the segment addition postulate from chapter 1 as a biconditional statement. So let's remember what that said. In that case, if I had points A and C, and a point B somewhere between them, that the length of AB plus the length of BC added up to be the total length AC. So we could write this as a statement: AB plus BC equals AC, okay? If and only if point B is between points A and C. Because I can say that those two segments add to equal the total length if B is between them. And I can also say if B is between them, that those two segments add up to be the total.